we're going to skip a couple of them so that you have a little time to, hopefully, we'll see, to do some of that. But we're not, may not do every single one of these. But find the slope of the line that passes through 4, 5, and negative 1, 3. So I put graphs here so we could graph those. So the point 4, 5, let's put us a dot right here, 4, 5, and negative 1, 3. So we've got those 2 points. So make sure your points are graphed correctly. And then we are going to pick one of these points. It does not matter whether you pick the top one or the bottom one. I'm going to pick the bottom one. Remember, for slope, we're going to rise first, so up or down first. We'd have to go up. How far? 3. I think just 2.
This is too small for me.
It probably is a little small there. So we would go up 2. That's our change in y.
It's over.
And over to the right, 5, 1, 2, 3, 4, 5. Yep. Over 5. So that does not reduce or divide, so just 2/5 would be our answer. Okay. Here's another one. We've got negative 5, 6, negative 5, 6. Here, we've got 0, negative 1 here. So if we're trying to find the slope of this line, you can pick either point. It doesn't matter. I think I'll pick the bottom point this time. So I would need to go up. And it looks like 1, 2, 3, 4, 5, 6, 7 blocks. So our change in y over change in x, the top number would be 7. And then I would need to go to the left. And that's 1, 2, 3, 4, 5. Since I went left, what have I got to do?
It's a negative.
It's negative, right? So I should get negative 7/5 for that one. Okay. All right, here. Okay, so one thing that you can do as long as your numbers are small enough to graph is you can just graph these. Whenever you take your exam, you will have graph paper. You can ask me for graph paper. I'll give you a piece. You can just graph, right? And then you can just find them from the graph like we've been doing. I'm going to skip those two. However, sometimes we have numbers. We're going to skip all the way to number 6 because I think you guys are doing okay with the slope. And we need some time. So all the way to number 6. So this method works fine as long as you have numbers that are small enough for you to graph fairly easily, right? But if you have really big numbers, if you start looking at like applications where we're talking about populations, towns, or something like that, where the numbers are in the thousands or millions or something like that, then you are going to need another method because graphing that by hand is no longer going to be feasible. So what I have here is I have asked us to find the slope of the line that passes through x1, y1, and x2, y2. Okay? These numbers behind the x and y, what is that called when we have like little numbers that are below? It's not squared. Squares are for like exponents, so it's like whenever they're up high. What is it called whenever you have, like if you're typing something out and you need to type in these little like lower numbers, you're going to go to the menu and you're going to say font, and then there's like this setting. What's that called? Anybody know? Not tiny numbers. Subscript. Subscript are tiny numbers that are below. Tiny numbers that are above. In math, we just call them exponents, right? But if you're talking about, sometimes you may be talking about these in like typing things out sort of way. It's superscript there for what you'll see whenever you're like working in a document or something. But these are little tiny numbers behind the x, and they are not exponents. They are just telling us it's the first x and the first y, versus the second x and the second y, right? So x sub 1 is how we read that, and it is, or sometimes we may just say x1, but it is not actually doing anything mathematical there. It's just saying this is the first x, this is the first y, okay? So I'm going to put 2 random points. I'm going to put one here and one here. I'm going to put them where they're not even, actually let me move this one. I don't even want them on the grid lines perfectly. That one right there, okay? So if I want to know the slope between these two lines, this one is called x1, y1, and this one is called x2, y2, or I could switch them around if I wanted, because it doesn't matter which point's which. These are unknowns, right? So if I pick a point to start at, I'm going to pick this top one just because I want to, but I could pick the bottom one if I wanted. If I start up here, I need to go, in this particular case, I need to go down, right? So this distance right here, the y-coordinate of this, I mean, it's 10 if I look at the graph, but I maybe am not exactly sure. So the y-coordinate of this is that y2, right? And then the y-coordinate of this point is the y1. So like if I label that on the, this axis here, the height of this point is y2, the height of this point right here is y1. If I want to know how far it is between y2 and y1, what can I do with those numbers? I could subtract them, right? So for my change in y over change in x, I would do y2 minus y1. Okay, so let's think about something similar here. Now we need to go left or right. In this case, I need to go left. Okay? And so what I'm doing is I'm going from this point right here over to this point. And I need to move my, let me move that x1, y1 actually so that I can label this on my x-axis. Sorry, let's... So, right here, my x-coordinate is x1. Right here, my y-coordinate is y1. I'm sorry. I need to look at x-coordinates. My x-coordinate is x2. Okay, if I want to know the distance between those 2 points, what can I do with those? Subtract. It is really important. If you subtracted the y2 first here, you got to do the x2 first here. x2 minus x1. Now, it does not matter which point is which. I could switch, whenever we do these problems, we're going to just choose a point to be x1, y1. So if you switch them, it's fine. Okay? This is our formula that we're going to use for the slope between 2 points. This is a big one that you need to know. It will show back up over and over and over and over and over again. Okay? This is your slope formula. Do you guys remember seeing this last year? y2 minus y1 over x2 minus x1. So, if we have points, we can just graph them. Or, in particular, whenever we get over here, well, actually, 7 is still pretty easy to graph. I could have graphed it. But whenever we don't have a graph, a lot of times it may be quicker to just throw it into this formula, right? So the formula, what letter do we use for slope most of the time? That's more than we need. Just the M is what's our slope. So M is the letter that we use for slope. I think it's a French word or something that it comes from, why they use M instead of, plus S is a horrible variable. S looks like 5 whenever you write it, and every once in a while I'll see a problem with the S in it, and I always hate it because it turns into a 5 in the middle of the problem. So, I think it's a French word, maybe. I need to look that up. All right, so what we're going to do is we're going to pick our points here. It doesn't matter which one's x1, y1. It doesn't matter which one's x2, y2. We can pick either way. We should get the same answer. Our work may look a little different, but we should get the same answer. So I'm just going to let this one be x1 here and y1 here, x2 here and y2 here. What is important is that if 4 is our x1, 7 has to be our y1. Right? I couldn't call this x1, y2. Because remember, this means first x, first y. They go together. Right? This means second x, second y. They go together. So my formula is y2 minus y1 over x2 minus x1. You don't have to write this as you do these problems. I'm just writing it for reference again. So the y2 is 8. It's always a minus sign in between. And then the y1 is 7. Then on the bottom, we're going to have negative 3 minus our x1 is 4. Everybody okay here? Remember doing this? Okay. All right, so 8 minus 7 is 1. Negative 3 minus 4 is negative 7. So we would get negative 1/7 for our slope. This is particularly helpful on problems like number 8 where the numbers are starting to get too big to graph, right? So even if you wanted to graph them, it would be difficult to do so. So we're going to use that slope formula again here, y2 minus y1 over x2 minus x1. And for this one, Anna Grace, tell me what you would do for this problem. Perfect. Perfect. Okay. This time we will get negative 18 over negative 32. What happens when you have a negative over a negative? It's a positive, so I'm going to go ahead and change those to positive so I don't forget. 18 over 32. That one's going to reduce. Okay, we can... that's 16 over 32, right? So this one, what can we divide both of those by?
4. Wait, no.
4 won't go into 18. I think it's just 2. It seems like something bigger should go into it, but I think it's just 2. So if we divide this by 2 and divide this by 2, we're going to get 9 and 16. Yeah, and that's all that we can do. So we'll have 9/16 for that. Okay, questions so far? All right. Okay. Johnny is running a race. At 2 minutes, he had ran 1.5 laps. At 10 minutes, he had ran 6 laps. For this time period of the race, how fast is Johnny running in laps per minute? Okay. So this is a little like the warm-up question that I gave you guys yesterday about the taxi. And when you tried to like divide it, you weren't getting the same number, right? So what we can do is we can turn these into coordinates, right? So at 2 minutes, he had ran 1.5 laps. At 10 minutes, he had ran 6 laps. So then we can use our slope formula to find the slope, because the slope is a rate of change, right? Slope and rate of change can sort of be used interchangeably. So, Giancarlo, what would I do for this one if I'm looking for that slope? So, your 2 is your x1. All right. And then this will be your y1 and your y2. So whenever we do that formula, what will go on top? Which goes on top? Y is on top. Changing y over changing x. You have just committed the most common error of all slopes. I promise I will give calculus a test, and they'll have to find slope. And out of the 12 kids, 2 of them will switch their X and Y's on accident. So you got to be really careful. There, I'm almost glad you did it so I could point it out. All right, so on top, what do we need instead, Giancarlo? Okay. And then on the bottom, very good. Now, some of you might have done that backwards. You might have done 6 minus 1.5 and 10 minus 2. And that's okay. That's fine. As long as he stuck with it, right? He did top minus bottom, top minus bottom. He stuck with his the way that he did these problems. So this is going to give us negative 4.5. And this is going to give us negative 8. Negative over negative becomes positive. And we want laps per minute. So this is our number of laps, right? And this is our number of minutes. And if we want laps per minute, this is really like a unit rate sort of thing. So where a lot of times for slope, we just want to keep it a fraction. For this, we want to do 4.5 divided by 8. And if we do that, we'll get 0.5625 laps per minute. So these word problems, these are the type of problems that you're going to see that you can use calculators on. All right, let's do one more. I think this is the last one, isn't it? Okay, so Caroline is saving money. At the beginning of the year, she had $320 in her bank account. By October, she has $11.50 in her bank account. How much money has she been saving per month? So, beginning of the year, we could call that 0, and she had $320. October, what should we call that? Let's call it 10 and $11.50. All right. So, Eddie, how would we do this for our rate of change? Okay, good. That's going to go on top. And then on the bottom, 10 minus 0. And you started to do that 320 first. You can do it that way. You just have to do 320 minus 1150, and then you'd have to do 0 minus 10 on the bottom if you did it that way. But this way avoids some negatives, so it's a little bit better. So 1150 minus 320 is going to give us 830 over 10, and this is dollars, and this is months. So if we divide by 10 here, we'll get $83 per month. So Caroline is saving $83 per month. Okay, questions? All right, so your assignment tonight is on Delta Math, and it's just practice with slope between 2 points. So, it's just going to ask you to find the slope between 2 points. I'm looking at this one. Let me remind you, what if you get 0 over 6 as your slope? What does that equal? That is 0. What about if you get negative 5 over 0 as your slope? Undefined. That is undefined. So you're going to see some that are undefined. It's going to have that button right there where you just click undefined and submit that as your answer. Okay? So you've only got to do 10 of these. You got about 15 minutes. So if you work really, really hard, you might have these done before you go. Yes? No, that is not for homework. We might do some of it. No, you don't have to do any of that. Just the Delta Math. Now, I will show you this also. We're going to have a quiz tomorrow. It is going to be on slope from tables and graphs.